Hi there. So today's review is on factoring cubic, quartic, and quintic polynomials. Just a quick review. You're going to start by ordering the polynomial from least to greatest. And then after you do that, you'll just break the polynomial down into prime factors. First thing you want to do is always look to see if you can factor out a greatest common factor. If that's possible, do that. Also, once you order it, if that first number, A, is negative, please factor the negative out as well. If the polynomial is a binomial, then check to see if you can factor again with the difference of two squares. So looking at the first one, we have a GCF of 2 and x. So I will factor out the 2x, and I end up with 2x squared subtract 16. And again, I took out the GCF, and now I'm looking for a difference of two squares. I get 2x times x plus 4 and x subtract 4. Next problem, I'm going to start by changing the order. So I want the highest degree first. The highest degree is a 3x cubed with the negative in front plus 12x. So now when I go to factor out the GCF, I'm going to include that negative. So the negative is going to factor out along with a 3 and an x, leaving me x squared subtract 4. Now I can factor the difference of two squares, getting negative 3x times x plus 2, x subtract 2. Example, I have a GCF of 2. So when I factor the 2 out, I still have an x to the 4th subtract 16. X to the 4th subtract 16 is a difference of two squares because x squared times x squared is x to the 4th, and 4 times 4 is 16. And so I have x squared subtract 4, or you can make this a plus, whichever, and then x squared plus 4. Now, x squared subtract 4 is a difference of two squares. So I will have x plus 2 and x subtract 2. And then I still have the x squared plus 4. Now, in pre-calculus, we're going to be working with imaginary numbers, and you can actually factor x squared plus 4. So did you know that that ends up an imaginary factor, and so I still have the x plus 2, I still have the x subtract 2, and now I can continue to factor as x plus 2i, and out of room, so I'll write it below, and x subtract 2i. All right. If the key is asking for reals, it would be this first answer, and you could just leave the x squared plus 4, but I did want to show you how that can factor as an x plus 2i, x minus 2i. In a difference of cubes, the formula for difference of cubes is a minus b, a squared plus ab plus b squared. Make sure you have that memorized. We've been using SOAP. S stands for this sign is the same as the original. This sign is the opposite of the first sign, and the last sign is always positive. So x cubed subtract 27 is a difference of cubes because x times x times x is x cubed, and 3 times 3 times 3 is 27. Here are some perfect cubes for you. We have 1, 8, 27, 64, 125, and 216. So when you see those with the difference sign, you may have a difference of two cubes. X cubed is a perfect cube. It's x times x times x. And 27 is a perfect cube. It's 3 times 3 times 3. So how you factor it is the x is the a and the 3 is the b. And you just plug it into the formula. So this is going to factor as x subtract 3 times x squared plus 3 times x, 3x, plus 3 squared, which is 9. By the way, this quadratic factor is always going to be imaginary. Looking at the next problem, let's go ahead and factor out a 2 and an x. That's the greatest common factor. X cubed plus 8 is what's left. And this is a sum of 2 cubes. So the sum of 2 cubes is the same formula, except for we're going to have different signs here. So you still have the 2x, and then you're going to have x plus 2, because 2 times 2 times 2 is 8. So 2 is your b, and x times x times x is x cubed. So x is your a. So a plus b. Then you have a squared. So x, if you square it, you get x squared plus, ooh, no, not plus, minus a times b, which is 2x. So there's your 2x. So subtract 2x, and then you do plus b squared, and b squared is going to give you 4. And there's your factors. So the next example, you always want to look for the GCF. So the GCF, you want to take the negative out because we don't want that in front. And then it looks like a 3 goes into both of those. And I have an x in common. So there's your greatest common factor, leaving me x cubed. 2 negatives make a positive 64. And then sure enough, I have a sum of perfect cubes because x times x times x is x cubed, and 4 times 4 times 4 is 64. So sum of cubes, I factor as, I still have the negative 3x, a plus b, so the sign in the middle is the same, so x plus 4, and then x squared, square the a, subtract, the sign is opposite, a times b, 4x, and then plus, always positive, 4 squared, which is 16. Done. These problems, we have polynomials to the 4th degree and 5th degree, but the first one, it's still quadratic in nature because we have this is to the 4th power, and then this is half of that to the 2nd power. You have 2 choices here. You can use U substitution. If you use U substitution, you would let U equal, in this first problem, the x squared. So U would equal x squared. So then you would have 2, and then x to the 4th is going to be U squared, because you have u, which is x squared, and you have 2 of those, which is x squared squared, which is x to the 4th. So 2u squared, subtract 13u plus 20. And to factor that, it's multiply to get a times c, which is 40, and add to get negative 13. My 2 numbers are negative 8 and negative 5. So this is going to give me 2u subtract 8 and 2u subtract 5. And that's because I factored out a half. Now I'm going to take the half and multiply it through. And so to do that, I'm going to divide the 2u by 2 and the 8 by 2. I'll cross that out. And so that's going to give me u subtract 4 and 2u subtract 5. Now, I'm not done because I'm not solving, or I'm not factoring for u. I'm factoring for, I've got the u as an x squared. So I've got to replace the u with x squared. So my final answer then is going to be x squared subtract 4 and 2x squared subtract 5. Now you notice that the x squared subtract 4 can be factored again as a difference of 2 squares. So x plus 2, x subtract 2 and 2x squared subtract 5. And now I'm really done. And I'll highlight that final answer. Okay, so looking at the next problem, if you don't want to use U substitution, you do not have to. But what you would need to remember instead is you do not have x times x because that's x squared. You would really need to have x squared times x squared, which is x to the 4th. All right, and then everything else is the same. So it's multiply to get a -5 and add to get 4. So 4 times 1 and so if you don't want to use U substitution, you really don't have to. Instead, you're going to set up your 2 parentheses like you always do. And just remember, when you have first times first, x times x is not x to the 4th. So your first times first is going to have to be x squared times x squared is x to the 4th. Then you're just going to do everything the same, multiply to get -5 and add to get +4. So you're looking at 5 times 1 with the 1 negative. So now I have x squared subtract 1 and x plus 5. Now x squared subtract 1 is a difference of 2 squares. So x plus 1, x subtract 1, and then x squared plus 5. Really, that's your final answer for this worksheet. However, I did want to remind you how you would factor the sum of squares. To factor the sum of squares, which is what we'll be doing later on in pre-calc, is you're going to factor it as x plus root 5i and x minus root 5i. Why the square root of 5? Because the square root of 5 times the square root of 5 is simply 5. And then you still do have your imaginaries. If you don't have your answer with the imaginaries right now, that's perfectly fine as we're just focusing on the reals. The next problem, you can see that I factored out a 2x, which was the greatest common factor. That's what I always start with. And then I was left with x to the 4th subtract 5x squared plus 4. Multiplying to get 4 and adding to get -5. My two numbers are -4 and -1. Being really careful here. So my GCF, I include it, 2x, and super careful here. This is x squared times x squared. All right, and then I have a subtract 4 and a subtract 1. Both of these are difference of squares. Ooh, I hope I have room. It's hard to write small with this pen. All right, let me try. So I'm going to come down here. So I have GCF of 2x and then x plus 2, x subtract 2, x plus 1, x subtract 1. Ta-da! So now we're going to factor by grouping. You can see that we have 1, 2, 3, 4 terms. And just as a reminder, the leading coefficient is a 2, the degree is a 3, and the constant term is -12. So out of the two groups, I split it down the middle, and I see a GCF of these two terms as x squared, leaving me 2x plus 3. Now, I will give you a hint. If you have a subtraction here, you always factor that subtraction out. So I'm going to take out the subtraction, and then I have an 8 and a 12, and I know that 4 goes into both of those, leaving me -4 into -8 is positive 2x. -4 into -12 is positive 3. And then when you're factoring by grouping, you look at these two parts and you look to see what's in common. And in common, you can see we have a 2x plus 3 and a 2x plus 3. So we're going to factor that 2x plus 3 out. So here's the 2x plus 3, leaving me an x squared subtract 4. Now that's a difference of 2 squares. So final answer, 2x plus 3, x plus 2, x subtract 2. Same thing on this one, so go ahead and pause the video and try the next two problems on your own. Final answer, 2x plus 1, x plus 3, x subtract 3. I hope you got it. So the next one is the same thing. We're going to factor the polynomial by grouping because there's 4 terms. I split it down the middle. The first group, an x squared, factors out. And I'm left with x plus 3. The second group, I'm going to take the negative. And then I'm still left with x plus 3. Out of my 2 groups in common, I have an x plus 3. And then what's left is an x squared subtract 1. A lot of students forget this 1 placeholder there, so just be careful of that. So I'm left with x squared subtract 1. This factors as x plus 3, x plus 1, x subtract 1. Try the next one on your own, and then I'll film the answer. And that answer is x subtract 4, 2x plus 1, and 2x minus 1. This time we're going to be looking at the polynomial function and looking at the graph and the equation. So I started by taking f of x equals 3x cubed plus 12x squared plus 12. And what we want to do is set f of x equal to 0. And then we want to factor. So I factored out the GCF of 3x, and then I continue to factor. Now what we're going to do is every factor, including the 3x, is going to be set equal to 0. So you have 3x equals 0, x plus 2 equals 0, and x plus 2 equals 0. Here you'll divide by 3, so x is 0. Subtract the 2, and x is negative 2. Subtract the 2, and x equals negative 2. Now these are called the zeros, and we see a 0 at negative 2 and a 0 here at 0. And because we get x equals negative 2 twice, we say that this has a multiplicity of 2 because we get the same answer twice, so multiplicity of 2. When you have even multiplicities, 2 is an even number, you get a bounce in the graph. So the graph hits the 0 and then bounces back in the same direction. When you get a multiplicity of 1, so I have this answer 1 time, m dot stands for multiplicity of 1, we get what's called a swish. And a swish means that the graph is going to go through the point. It swishes through the point. So swish right here. Putting together the connection, we don't have a constant term here. So you could think of this, the constant term is 0. So the y-intercept is 0, and the constant term is also 0, looking at the connection between the equation and the graph. On this one, you could use U substitution, or if you want, you can just factor using, oh, I don't feel like red. Let's go purple. So you can factor this as x squared times x squared, which equals x to the 4th. All right, and then we're multiplying to get 4, but we're adding to get negative 5. So that's going to be negative 4 and negative 1. Both of those are a difference of 2 squares. In place of the g of x, we're going to put in 0. This is an equation now because of the equal sign. And x plus 2, x minus 2, x plus 1, x minus 1. Now, although these look the same, our multiplicity on each of these is actually just going to be 1. The reason why is you have an x plus 2 equals 0. So when you subtract the 2, you get x equals negative 2. This one, you're going to get x subtract 2 equals 0. So x is equal to 2. X plus 1 equals 0. So x is equal to negative 1. And x subtract 1 equals 0. So x is equal to 1. Now you can see, looking at all of my solutions, negative 2, positive 2, negative 1, positive 1, that the multiplicity on all of those is 1 because they're all different answers. So you can see I have a swish at negative 2, a swish at negative 1, a swish at 1, and a swish at 2. It swishes through the point or the 0. Looking at the constant term is 4. And what's the y-intercept? Here's the y-axis. So the y-intercept is right here, and the y-intercept is also 4.